hopefully by now you are able to actually try quite a few of these yourself without the explanation. So let's just go through the answers. Probability of A is 0.7, probability of B is 0.6, and the probability of the union of A and B is 0.9. So, as you may have guessed, hopefully by now, that we're going to be drawing a Venn diagram. There's just about enough space to give myself that time. So probability, if we call this A and we call this B, so if it's an A, it's 0.7. So do we know what that number is? No, so we'll call it X. Do we know what this number is? No, so we'll call it Y. And we're not told anywhere what B is, apart from we know that the whole of B is 0.6. So let's call this Z. We know, let's work backwards just to keep it interesting. Probability of A and union B is going to be X plus Y plus Z equals 0.9. We know from probability of B, which will be Y plus Z, that is probably the worst Z I've ever done. Y plus Z is 0.6. So recap, A and B, A union B means all of this stuff, yeah? So that's why I said X, because it's there. Y plus Z is 0.9. Y plus Z, because we said probability of B, so it's both in the intersection and in the crescent. Y plus Z is 0.6. From here, actually, I could get a statement about A, which would be X plus Y equals 0.7. However, we won't actually need that, not just yet. Notice here, partially because of the way that I've written it, hopefully it's quite easy to see that we can substitute Y and Z here, Y plus Z, for 0.6. We know Y plus Z is 0.6, so let's take this down here in a different colour and say, well, X plus, and this bit here, Y plus Z, which is that, therefore is 0.6, so plus 0.6, put this guy here instead of that, is 0.9. Okay, so just substitution, Y plus Z is 0.6, so therefore place it there, and we've got X plus 0.6 equals 0.9. Now if we take away 0.6 on both sides, X is 0.3. If X is 0.3, and we know that over here, X plus Y is 0.7 from this statement over here, then 0.3, if I rewrite this over here, 0.3 plus Y equals 0.7 minus 0.3 on both sides, and suddenly you've got Y. Y is 0.4. And if you know that Y is 0.4, you can use this, so Y, which is 0.4, 0.4 plus Z equals 0.6, so Z is 0.2. That last bit you didn't really need to do, because you needed to work out the union, so the intersection of A and B, and the intersection of A and B is going to be, let's use yellow, because everyone likes yellow. The intersection of A and B is going to be this guy here, so where they overlap, which is 0.4. So that is the probability of the intersection A and B. Remember 0.4, as we're looking at probability, could be written as a percentage, so 40%, and it could also be written as a fraction, 2/5. I got that because 0.4 is 40 over 100, or 4 over 10 divided by 10, which simplifies to 2/5. So any one of these will be correct, but because of the way that we've used decimals here, you probably wrote 0.4. So 0.4 will give us the answer mark. Looking at a few Venn diagram problem solving questions now. So with the new GCSE, they could very easily, and have done in some of the practice papers, put in a few Venn diagrams just to try and test the new knowledge, but also add an element of problem solving, because you can quite quickly generate things like quadratics which you could solve and then find out, for example, what the unknown variable x is. Alternatively, they could have simultaneous equations or setting up some sort of equation to solve a problem. So I've got 8 questions that you can pause the video and try, and then I'll reveal how we would work out the answers towards the end. First of all, though, just a very quick brief on Venn diagrams. This video is assuming at least that you have studied Venn diagrams at least a little bit, but I will go through a couple of the very important key elements to remember. So, for example, I might have something that says PNS. So looking at this question where we've got P is this circle here and S as this circle here. If we said PNS, that N is the intersection, so P, it looks like an N, but it's that symbol there. It's that part there. So the intersection, so if you see this, what it actually means is the bits that overlap. PNS, the intersection of P and S. Other notation you might have is P union S. So it looks like a U. P union S. So it's going to be that symbol there. And if it's in the union of P and S, then we're talking about everything that is in both circles, including, so the P and S circles, including the intersection. So it's all of this stuff here. Other ones might include P dashed. So if you get something that says P dashed, then what we're saying is instead of it being P, where the union of P would just be everything inside here, P dashed is going to be the opposite. P dashed is actually going to be everything that is outside that circle. So all of this stuff here. If you have any numbers, obviously not including what's outside the rectangle there, but anything excluding what's in P, if that's what we're talking about. Okay, and you can have the dash notation for anything. The dash notation just means not. So if we would say, for example, P, U, S, and then it was union dashed, then it would be everything outside the union. So all that stuff. So the dash notation means not in the union of. Okay. So now we're looking at a Venn diagram question with a little bit more union and intersection notation. So no union here actually, but pure intersection notation. But it's a probability kind of question. The Venn diagram shows the number of students who walk to school, so all of these students walk to school, and the number of students who walk home from school, so all of these students walk home from school. Note that 25 must be the ones who do not walk to school or from school. How many students are there altogether? Well, if you want to work out the total, you just need to add these numbers. So it's going to be 10 plus 80, which will give us 90, plus 15, plus 25. So 130 students. So we did 10, 11, 12, 13. So that's how we got that. So 130 students. Work out the probability of them intersection. So what's the probability? That P there, probability of them intersecting, so both walking to school and from school. So if you worked out previously, and remember if you've got part A, part B and part C and part C are very likely to be linked to what you've done previously. So work out the probability of them both walking to school. So it's just an understanding that the intersection is this bit here. So it's 80. 80 is the part, and the total is 130. So the probability is 80 over 130. But please do not think that that is finished. You have to simplify your fraction. Now, a lot of people would do something like that and not really explain it much. They'll explain it very quickly, saying, "Oh, we've as they've got zeros, you can cancel them out." What we're actually doing there, and it's important to understand this, is that we're dividing by 10. Okay, we've noticed that if there's a 0 on the end, we can divide both the top and bottom by 10 very quickly. So 80 divided by 10 is 8, 130 divided by 10 is 13, so that's why we can just write 8 over 13. Okay, so this requires an explanation as well. So 8 over 13 is my probability. Describe in words what P, the probability of S intersection H means, represents. So what it represents, okay, is in words the probability that a random student walks both to school and home from school. The probability, which is the part which is usually missed out on this answering this question. So most students will write student walks to school and from school, or student walks to school and home from school. But you need to put the P in. P is the probability. So it's the probability that a random student walks both to school and from school. Apologies for the handwriting, it's very hard to write on this thing. But yeah, that's what it would be. So I'm just going to rub that out so I've got some extra space for the last question, which is, what's the probability that a student chosen at random only walks one way, either to or from school? And the final bit is walking to school or from school, which was 15 plus 10 equals 25. So that's 25 out of a total of, as we worked out before, 130. So from this part was 130. They're divisible by 5. We know that because one ends in a 5 and the other fraction, denominator, of the fraction ends in a 0. Divide them both by 5 and it's 5 over 26. Okay, if we weren't sure about that, you could do 130 divided by 5. Remember, bus stop is a skill which I'm sure will turn up. So 5 into 1 is 0, remainder 1, 5 into 13 is 2, remainder 3, 5 into 36. So that's how we got that. Does it simplify? No. So that's our answer. Question 7 now, and this is another way they might introduce a problem solving kind of Venn diagram kind of question. And we have the numbers in existence of 1 to 10. A is even numbers, B is the numbers greater than 6. So working out the probability that you'll pick A. Let's draw our Venn diagram. This would be A, this would be B, and that's all our numbers in existence. So numbers I'll do again in a different colour just to highlight them. So even numbers and numbers greater than 6, well, first of all, the numbers between 1 and 6, which are not even, will be outside, so 1, 3, and 5. A is the even numbers, which if we ignore B at the moment, the even numbers less than or equal to or less than 6 would be 2, 4, and 6. Now, even numbers that are greater than 6 will be 8 and 10, leaving our numbers greater than 6, which are odd or not even, being 7 and 9. And we can just check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got all the numbers here. So we can start tackling the problem. Let's go for brown. Probability of A is 1, 2, 3, 4, 5. So 5 out of a total of 10. So 5 numbers are in A out of a total of 10. So that's half. Probability of B is 1, 2, 3, 4. So that's 4 out of 10, which again simplifies. This time though, divide them both by 2, and it's 2/5. Probability that is in both the union of A and B is 1, 2, 3, 4, 5, 6, 7. 7 out of a total of 10. And the probability that it is in the intersection of A and B is 1, 2. So 2 out of 10. Both even numbers, so let's divide them by 2. And so the probability is 1/5. Now we're using a Venn diagram probability question with algebraic notation given to us. So we've been given here x, and the intersection of A and B is 2x, and B without the intersection of A and B is 3x. Outside the Venn diagram is 4x. If we want to work out the probability of A, then what we're looking at is everything inside the A here. So PA would be x plus 2x, which would give us 3x, out of a total of x plus 2x, which is 3x plus 3x, which is 6x plus 4x, which is 10x. 3x over 10x simplifies. If you divide both top and bottom by x, it's going to give us 3 over 10. P, B dashed. Remember, B dashed means outside of B. So everything outside B, which would be this and this. So x plus 4x is 5x, out of again 10x. We've added everything up, so out of the total, and that simplifies to 5 over 10, which again simplifies, dividing both of them by 5 to a half. Probability of A in the union of B is going to be this, this, and this. Add them all together, 6x over 10x. Again, divide by x, and again you can simplify them. 6 over 10, divide both of them by 2, and you get 3 over 5. So your probability is 3/5. The last one, and the tricky one, the probability that it is not in A, in the intersection of B. So it's not in A, but the intersection of B is going to be all of everything that is not in A dashed, but it is in B. So it'll be here. Okay, the intersection here we're not using A dashed and B. We're not using, but it is going to be in B. So this notation means just this bit here, excluding this one. So it's going to be 3x over 10x again. However, that simplifies to 3 over 10, and that will give us the answer to all of these. So this problem is looking at a Venn diagram problem with 80 cars, 24 black and have traction control, 43 have traction control, and 31 are black. It might look quite obvious at first, but it's actually incorrect to use this statement and say, well, if there are 80 cars, minus 43 to give me 37, so therefore 37 out of 80 is the problem solved, because the probability that the first car does not have traction control must be those that do have traction control, well, minus the total from that, so 80 take away 43 must be the ones that don't have traction control. But that's actually incorrect. We need to use a Venn diagram to show our solution. So 80 cars overall, 24 are black and have traction control. So let's go for B and T. But this time note that we have been told black and traction control is 24. So let's do our numbers in a different colour. So black and traction control, so the intersection here is 24. Black and traction control, 24. 43 have traction control, so let's call this X, because we know that 43 is the total of 24 plus x. Okay, because we're told here, sorry, 43. 43 is the total of 24 plus x. 43 have traction control, so that must be these two added together. 31 are black, so let's call this y. And we know the black is y plus 24. So y plus 24 equals 31. So straight away we can actually work out what x and y are. So let's take this equation first. If 24 plus x equals 43, then if we take away 24 on both sides, 43 take away 43, subtract 24 is going to give us 19. So x is 19. Y is, so if we carry on down here, minus 24 on both sides. And you're going to get y equals 7. We know that there are 80 cars overall, so there must be a number outside here to make everything add together to add up to 80, because it is possible that cars are not black or do not have traction control. So to work that out, which you will need to do, because our question is do not have traction control. So traction control is here, so it must be all the ones that do not have traction control. So it's going to be 80 subtract 7 subtract 24 subtract 19. You could have added all these together and then subtracted that, which would be 26 plus 24, which is 50. So your answer is going to be 30. So there are 30 cars on the outside here. Therefore, the cars that do not have traction control, what's the probability of the first car that does not have traction control, will be all the ones outside traction control out of the total of 80. So that is 37, that one, and that one, out of 80. Now, 37 is a prime number, so we know that that is our answer. Final problem now, and a snack bar kept a record of 100 sandwiches sold one lunchtime. 20 had only meat in them, 25 had only cheese in them, 10 had neither meat nor cheese in them. How many sandwiches had meat and cheese, any combination? Hopefully by now we can actually sketch our Venn diagram. And let's start filling in. So we know that in existence there are 100 in the sample. Let's call this meat. Let's call this cheese. And our numbers. 20 had only meat. Now, in here they have meat, but here they have meat and cheese, so only meat must be here. 25 had only cheese, so for the same reason it must be here. 10 had neither meat nor cheese, so outside. How many had some meat in them? Well, if there are 100 in existence, you've used up 20 here, 25 and 10 here. That's 100. If I add these all together, that's 55. 100 subtract 55 is 45. So there are 45 that have both meat and cheese. So to answer the question, how many had some meat in them? Well, these have only meat. These have meat and cheese. So some meat only includes 20 and 45, because these ones, remember, have neither meat nor cheese. So there's 20 plus 45, which is 65. And we don't want it as a probability. So how many sandwiches? 65. Some cheese in them, 45 plus 25. Inside this Venn circle is the cheese, so 45 plus 25 will give us 70. Either meat or cheese in them will be all of these added together, or just 100 subtract 10, 90. And those are the answers to your questions.